Hey guys, I have your notes here for section 5.5, and I have some good news for you. We are not going to do the front page. So I'm just, that's a nope. It's kind of a tiny topic, takes a considerable amount of work, and it's never come up, like on the AP test or final exam or nothing like that. It's kind of a decent lead into Calc 2, but we cover it enough in Calc 2 that I really don't need to cover it in Calc 1. So, we're just not going to do it. That'll save us some time. We are going to talk about the back side of your 5.5 notes. That's linear approximation, or it's also called linearization. Before I get into the math that's involved, let me give you like an overview. So, I have graphed a blue function and a red tangent line. The tangent line touches the blue function at x equals 1. Okay, so I shouldn't have said anything too confusing at that, just yet. Now, I'll go ahead and give you my equations for my blue yucky function, also my red tangent line. So this is the equation for the blue function. I literally typed that in my graphing calculator, and the blue is what it gave me. This is the equation for the tangent line to this function at x equals 1. So yes, I took out a piece of paper, I did the derivative, I plugged in 1. I found the slope at 1. I also found the point, 1 comma something. So I plugged in 1 to f, got the point, 1 comma 2, and so on. So anyway, made the equation of my tangent line. Okay? Keep in mind, the blue function and the red tangent line touch at the point 1 comma something. It's actually 1 comma 2, but whatever. Keep in mind, 1 comma 2 lies on this function, 1 comma 2 lies on this function, okay? Now, here's what I need. Here's what I propose to you. Without a calculator, can you give me the answer to f of 1.1? No calculator. Think about what that would involve. So you're going to plug in 1.1 to f, right? You're going to square it. Okay. You're going to add 3. And then somehow, miraculously, you are going to figure out what the square root of that decimal is. How the heck are you going to do that? That's going to be pretty tough. This function is fine for plugging in 1, because 1 squared is 1 plus 3 is 4. That square roots nicely. Anything else is kind of yucky to plug in. So, but I really want an answer to this. I want to know, when x is 1.1, what's y? So how about this? Keep in mind, you don't have to call that 1.1. You could call it 1 1/10. Or how about this? Change it to a mixed number and call it 11/10. How about that? Does that make it easier to plug in here? So take 11/10, the fraction, square it, add 3, so get a common denominator, and then square root that fraction. No, that is still not an easy task to do. May I propose an easier solution? I'm asking for you to plug in an x super close to x equals 1. Why? Well, think about this. That's where my tangent line is. So my tangent line touches the function at 1. My tangent line, my red tangent line, and my blue function have the same y value when x is 1. When x is 1, the red y value is 2. When x is 1, the blue y value is 2. They both have the same y value when x is 1. What about when x is like 1.1? Do they have the same value? No, but are they super close? Yeah. They're like almost touching. They're touching here. They're almost touching here. Does that make sense? It's called linear approximation. We're going to use a line to approximate a y value instead of our yucky function. One more time. When I plug in 1 to the blue function, I get 2. When I plug in 1 to my tangent line, I get 2. They have the same y value when x is 1. What about when x is 1.1? What if I plug in a number super close to x? Does it really matter which one I plug it into? It doesn't. Plug it into the easier one. So if I plug in 11 tenths, that is not hard. 11 tenths, that's going to be 11 over 20 plus, get a common denominator. That's not hard. 11 over 20, 30 over 20. 11 over 20, 30, 41 over 20. 20 and 2 and 1/20th. Answer. See what I did? Instead of plugging in my x into here, that was yucky, I used my tangent line equation. And I just used a fraction version instead of a decimal. These have fractions. I used no big deal. Now, is this a good idea to do if I asked for f of 5.1? No. If I want you to plug in 5 something for x, 1, 2, 3, 4, 5, think about how far apart your tangent line and your function are going to be. No, the red would not be a good approximation of the blue way out here at 5. Where is it a good approximation? Only right around where your tangent line is. You can go just a smidge to the left or just a smidge to the right of where your tangent line is. Plug your number into your tangent line versus plugging your number into your yucky function. I hope that makes sense. That's big picture. Linear approximation. You're using a line to approximate a y value instead of using your yucky function. Okay. Where is it? Here it is. All right, so I'm going to have you kind of write mathy what I just said wordy. So I have a blue function and I have a pink tangent line. They touch at one point. What is the point? It is this, comma, this. So a comma f of a is a point on f. Turns out a comma f of a is also a point on your tangent line. x equals a. Your blue function and your pink function have the same y value. Okay? So, again, what we're going to do is we're going to use a tangent line to a function to approximate a y value with an x that's super close to this number. Whatever a is, we can plug in numbers super close to a. We have a choice. We can plug them in our yucky function. You're not going to want to do that. Or you can plug them into your tangent line. That's what you're going to want to do. Okay? Well, dang. Apparently you don't have the example written down. Well, here you go. The example is find the linearization of f at x equals 0. Use it, the linearization, to approximate the square root of 1.02. Find the linearization, means find the tangent line. Find the tangent line for this function at x equals 0. Then use it to approximate this. Okay, one step at a time. Let's find our tangent line. How do we write an equation of a tangent line? We need two things. We need a point on the line, which also happens to be the point on the function, right? We need a point on the line, and we need the slope of the tangent line. Derivative. So, let's start. I guess start by taking a derivative. The derivative of that is 1/2 1 plus x to the negative 1/2 times the derivative of the messy. So that's going to be 1 over 2 radical 1 plus x. That's the slope of my tangent line anywhere. It tells us where we need it, x equals 0. So I'm going to plug in 0. And I get 1/2. That's the slope of my tangent line when x is 0. Two things to write an equation of a line. Slope, point. So I need a point on f, so I'm going to plug in 0 for x to f, and I get 1. here I go. Here's my tangent line equation. Tangent line. The pink line that's pictured up there. Y minus 1 equals slope, parentheses, x minus 0. Come on. There we go. All right, that's the equation of my tangent line. Pink line, blue function. Now, it doesn't give me an x to plug in. It did say, find the linearization when x is 0. So I did that. I found my tangent line when x is 0. That's the nice point, right? Remember here, I showed you that my tangent line and my blue function touched at 1. Okay, well, in this case, my tangent line and my blue function touch at 0. Down here, I told you what I wanted you to plug in. I haven't told you what to plug in. But hey, it better be super close to 0, right? 0 is where the pink line and the blue function touch. I'm asking you to plug in something to your tangent line instead of this. But it better be something really close to 0. I can't ask you to plug in something really far off. That wouldn't be a good approximation. It has to be super close to 0. What is it? Well, here's ultimately what I want you to find. This is what your function looks like. This is what I want you to approximate. Use your brain for just a minute. Do you think I want you to plug in 1.02? Two things are wrong with that. One is 1.02 is too far away from 0. The other thing that's wrong with that is if I want to get an answer to this, I'm not asking you to plug in 1.02 to x. Think about it. If I plug in 1.02 there and then add 1 to it, well then I'm approximating 2.02. No, this is what I want you to approximate. How does this compare to this? Compare what's in your function to this. No. Here's what I need from you. Here's what your function is. I only want you to plug in 0.02. Hopefully you can see what I wrote there. This is what it's asking. This is how the setup was. So the only x that you need to actually plug in is 0.02. Now, is that close? Oh yeah, that's close. That's close to 0. So let's plug in 0.02. Try plugging it in there. You just get this. We don't know how to do that. Hey, let's plug it in your tangent line instead. Let's plug it in your tangent line instead. Let's try it. Let's go. Y of 0.02 equals 1/2 times 0.02 plus 1. Okay, well, that's not great. So no big deal. Let's just change that to a fraction. .02 is a fraction. Well, how do you read it? You would say this is 2/100. 2/100. my gosh, so easy. Cancel your answer 1/100th. So y, plugging in 0.02, gets me 1/100th, or 101/100. That's your approximation of this using the tangent line to sub it in versus this to sub it in. Okay? So think about where your tangent line has to be. And I know, every single one of you can take a function and find the equation of a tangent line. Once you get your tangent line, figure out what do I need to do, what do I need to plug in, and then plug it in to your tangent line.